Hey guys, this is Chen. So today I'm going to share you some basic techniques on running Rasch Dichotomous model in R. So first of all, we need to install the package. By the way, and if you have the R book, which is the web link, so it's strongly recommended you to open that first, because on each block, code block, you should see like a copy and paste button. So once you have that button, you could just easily copy and paste the code to your console, to your R Studio. So it's gonna makes you easier to do all the codes, to run all the codes. We need to load it like the package that we need for this analysis. So we have like 4 different packaging here. So the first one actually is the one we need to focus on today. So the TAM actually is the abbreviations for the test analysis modules. So it's actually it's like little bit different with the WinStep software. So it applies marginal maximum likelihood estimation. So which is different with the WinStep software. It used the joint maximum likelihood estimation, which is JMLE. And in here we use MMLE. So it's a little bit different, and I will cite all the references down the website so you can see all the differences if you're interested in that. So just keep in mind it's different estimation method. Okay, so let's load, and I've already have these packages on my console, so I don't have to reinstall them. But if you don't have these packages and very first time, you need to install it before you run it. Okay, so second, we need to load the data. So keep in mind, every time you run something in R, you need to load your package and load the data as well. Okay, in here we have the data already on our desktop, and make sure you set here, see the desktop, and click more and set as the working directory. So this steps helps you to, if you have like your file, like your data files on the desktop, it could help you to locate that. Okay, so once and this packages help you to open that specific type data. Okay, so when you click that, and let's read the data. Now you can see the data is in here, and you can have a preview of your data. So in here, since it's a dichotomous Rasch model, so all these test takers have like dichotomous response, either 1 or 0. 1 is equal to correct, 0 is wrong, right? So, and also they have the grade and their student ID. But in this analysis, we don't need that. We don't need that information. So in the real informal analysis, we are going to take these 2 columns out. Okay, so let's back to the console, and let's do the next step. First of all, we need to see like a summary of our data, right? So you just put summary in here, and we can check the summary here. So the very important critical step in here actually is to see whether there is NAs, which is the missing data. So because like this data is prepared data, so we didn't see any NAs. So if you use the summary functions, it should have like NAs if you have missing data in any of your columns, right? In here we don't have the missing data, and also we can check besides these 2 columns, because actually they are the categorical variables. So we are not caring about that. We are caring about like the text 1 to text 10. And then we need to know what's the maximum and minimum scores for each of the text. So in here, the minimum, like all are 0, right? Which is good. And the maximum is all are 1. They are all 1. So which means all these test items use all the categories. This is vital to some Rasch analysis packages. Because some of the package ask you to have like the balanced answer for different categories. So you have to have these all like the same categories to each items. Otherwise, you cannot run the whole analysis. So that's the point. Okay, so now we use the describe functions from the HMISC. Actually, the reason I recommended this package is it will have a really neat display on your data. So now you can see this also give you another like quick review, and also like these functions like already know like your student and grade are the categorical data. So it shows missing, distinct. In here, test 1. So you can see in here, you can see the means and the sum. So because like pretty much this is how many people like answer the question correct. Because you remember like 1 is correct, the coded for correct. So there are 400 ones, which means because like the total number is 425, so 400 out of 425. So that's where the means come from. Okay, so when you go through all the means, you can pretty much see here, task 6 is like the easiest task because it has the highest mean. And let's see, I think probably task 9, if you didn't find another lower score. Yeah, task 9 is the lowest. It's the hardest test, which has the lowest mean, right? Okay, so let's go to next step. And let's run the dichotomous Rasch model. But before that, we need to trim the data. So every time for all those, and even in the for the following lectures, we just don't need that many informations actually. So all we need is students' response matrix. So in here, so column 1 and column 2 is not needed for the analysis. So we need to use that code to take out the first column and second column. Now we have the Rasch data. You can see pretty much just the response matrix. Okay, and then let's take a look. So you can use the hand always to take a look of the first 6 rows of your data. Okay. Let's starting to running the Rasch Dichotomous model. It's a easy function to use. Actually, it's just TAM. So you can use the TAM, exactly the name of your package. So when you use the TAM on your data, so you can get your models. Actually, it already shows you some information, like basic informations, like the deviations, like the iterations. So like the total iteration here is 26, and okay, so that's all other iteration steps. So basically it used the E and M step. So if you have the CDM class before, so I think Dr. Ma gave a really great description on like what is E and M step. Okay, so and here we can see all the item parameters. So basically this XSI actually is the estimation for the item difficulty. So basically in here it shows you the different locations on logit scale to locate each task's location by their difficulties. So like the lowest is the easiest, and the highest, I think it's in here, is the hardest item, right? So if you sort it by that, you can have the tasks like ordered by the difficulty. And then you have the regression coefficients, you have your variance, you have your reliability, and note that in here the reliability is used the EAP method. Okay, and also the great thing about like this function is it gives you like the times at running all the data. It's sort of critical. It's important to when you are running like a large data set. So in here, this might take minutes, sometimes even hours to run like a large data set. Okay, and now since we have already run the model, so we can have the summary to the model. Summary it. Okay, you summary your model in here, so it gives you a basic information, and also you have this like relative fit statistics. So, and this AIC BIC is provided you some index. So when you compare it to other models, so these are the relative fit statistics. And also you have some basic things like number of iterations, log likelihood, number of persons used. Because like in here, if there is some missing data for one person, so the system might kick that person out. So, and also if a person didn't use all the categories, it might also have been like kicked out by the systems. So let's say if a person have all the response as 0, so it could be kicked out by the function. And then we have the number of items, 10, and estimate parameters, and so basically we have 10 item parameters, threshold parameters. And since this is the dichotomous model, so each item only have one parameters. But if you are going to run in some partial credits or rating scale, so you should have more threshold parameters. And then we have variance and covariance parameters. Now it can give you the basic informations on like the correlations, regression coefficients, and in here this is your category. And things you see here is because every item only have one category, which is 0 and 1. So it's the same with your item difficulty, right? So about like when you're going to run some partial credit or rating scale models, you should have like different categories and with different locations, logic scales, and also you will have like a mean difficulty for that specific item. So this is the item beta. It's the same thing with the, you see the like it's just different name, but actually it's the same difficulty in here. So let's go to the next step. Okay, so we use the LRT right map. Right map actually is the same with the variable map. So this is the package to load that function. Okay, so right map. Okay, now you can see the right map on your right. So basically, it put all these items on the logistic scales on your right side, and then you see the left side. It is a histogram of your respondents. So pretty much we can see our responses like follow the normal distribution, right? And you can see like the mean is pretty much 0, right? And so which means like the test takers are like kind of like follows like a really expected like great distribution that we expected. And then we should have different items, say also. So you can see basically in here you can see like the most respondents like are higher, their location on the logistic scales are higher than these tasks. For this test which means like the test is kind of easier comparing to our test takers. Okay, so then we can have like specific item parameters and the person parameters. Now let's print out the difficulties. Since I've already showed you the difficulties, but you have to know where, in here, your dichotomous Rasch model should have like a long list. So you need to know where to extract your the data that you need. So in here, A dollar sign is if you want to take something out of that list, so you need to use that dollar sign. And then we put like the difficulty in another value. Okay, and then we can see like this is a whole list of the difficulty. So it also provides you the standard arrow in here. And you can have like a really simple function like main to calculate like the main difficulty for these items. So I think yeah, I put the value in here. So the main difficulty for this item is negative. Since you can see in our right map is basically like the main of like the person's ability is around 0. So you can see like the person's ability is kind of like 2 logit unit higher than the mean of the test. That's why I said our test takers like a higher on a higher scale comparing our logit scales comparing to our items. And also you can see the different standard deviations on the item difficulty. So the standard deviation is 1.56 is kind of good. So that means like your test has like easy items and difficult items. So this is a like well-made test, just a little bit easier to comparing to your test takers. Okay, and then we can also, since we have like a histograms for our respondents, so let's print out a histogram for these items. Now you can see the items. So most of the items still are okay. So because their difficulties from -2 to -1, but also we have like way easier items in here, which is not good. So in an ideal situation, we hope like everything could be like a normal distributions around 0. Right, so that's why I say like this test is a little bit easier, and you can see the reason is in here. So like we have 3 tests. I think that's three test items, like way too easier comparing to our test takers abilities, right? Okay, so let's print out the item fit. So this is the item fit. So here I store the item fit values in this Dichotomous item fit. Okay, so here you can see all your item fit. So in here we have the outfit, outfit T, and outfit P. So basically it's a little bit different with your result in your win step. So your win step give you a Z score, but in here instead of Z score it provides you a T score. Also, the great thing is we are not sure like what is the Z and T, like how much abbreviant is abbreviant. Is it like abnormal one? But like P is kind of like easier to detect. So whenever like that P is less than like 0.01 or 0.5, so it could be like a really problematic thing, right? In here you can see like our task 4 is less than 0.01, and task 6 is less than 0.01. I think the task 4 probably is the, let's go back to see task 4. Okay, task 4, and if you see the mean is task 4 is okay, but in here, so when you see the outfit, task 4 is not okay. So that means like something's going wrong in here. So yeah, because when you check the outfit T and outfit, the outfit is like a little bit higher than 1, right? And infit also is higher than 1. Okay, and let's print out the item parameters. Oh, that's the item parameters. So let's print out the person parameters. Okay, so this is the person parameters. Let's store the values in the person abilities. So we use the TAM, LW, LE functions. And let's see what's in here. So the theta here is the place, the location to attract the ability parameters for person abilities. Okay, so when we get main, so we can see our it's around 0, right? It's negative 0.05. It's almost like it's really close to 0. And we can also have the standard deviation for our test takers. Okay, so it's 1.28, and the main for standard deviations arrow, we can also use that to see. So the main person abilities arrows is 1.02 is nice. And also we can have a histogram to show the student's ability, which is the theta. See, when you check this, we saw like the most of the people, they are like follow the normal distributions. But another thing is we saw some like outliers. So pretty much their ability is kind of like matched like the lowest part of the scores, right? So we do have some outliers in here, so they have way lower, and some will have even way lower than -4. So way lower than the test. And then we can calculate the person fit. So that's the same thing, because like the person, we have 425 observations, so that's why I used the head. I only want to see 6 of them, right? And you can, because this dichotomous person fit in here is a whole list of 425 person in here, so you can always like just click on that. You can see like, okay, person ID 4 has the lower risk outfit, right? If you want to see the high risk, so the person ID 3 and person ID 94 has like the high risk outfit ID. So it's kind of really easy to help you to find all these outliers in here. So if you want to see like the lower risk, you just click on here. There's a little area in here. So in here is the lower risk item infit. Person infit is 0.15. Actually, a bunch of people have these values, right? And the higher risk is 2.20 as ID 94. He also has like the higher risk outfit. Okay, so let's summarize the results. So basically, we need to set up content for the table. So in here, I created an empty data frame, and then we can set the names, so all the data that we need, like test ID, proportion correct, and the delta is the item difficulty, and SE. And then I put all the information that we preloaded into our data frame. And then that's ordered by the proportion correct. So we have table 2 in here. Okay, so this is the 10 items. The test ID 6 has like the highest proportion correct, which the delta, which is the item difficulty, is the easiest one, right? This is the standard deviation for that item. And we can also see the outfit is way lower than 1. Infit is a little bit lower than 1. So when you check all these proportion correct, you can see like item 9 is the hardest one, but actually when you check the delta, it's 1, the hardest one. And so if you want to looking for some like ideal, I would say like this ID 7 is okay, because like the outfit infit is 0.86 and 0.94, which is close to 1. Actually, item 10, I guess, is the perfect. The reason item 10 is the perfect one because it's like almost half and half. Half one get it correct and half get it wrong. And you can see the outfit almost really, they are all both close to 1, right? Like the closest to 1, which is like expected, like really ideal item. So it's like normally difficult, right? Half of them got the item correct and half of them get the item wrong. Then we can have our person calibration tables by using here, the coding here. So basically I created another table 3 to, so this is the once for all example, because when you retrieve all the data in your PC model, which is partial credit, and all the rating scale models, basically you have you follow the same rules. You extract your data from these, like the person abilities, like person fit. So in here you use the $ to take out these data. So I'm just showing you an example in here, but I won't show you any examples in the following lecture, because they're the same thing, right? So now we have this person table in here. So the person table is table 3. So let's see. Okay, so here for each test taker, so we have the test IDs, proportion correct, CDAS. And since we only have 10 items, so they're either 0.1 or 1.0 to 0.0, right? So actually the lowest is 0.1. We can have 0.0, otherwise this person is gonna kick out by the system. So basically you can have all the information in here, and I think that's pretty much. And in here we can I can show you a way to print out the the tables in a really neat, like that. Actually, this is like the R code for you to print out a beautiful tables, because in here you just see lots of slash, but in print the table 3, which is our person table, also in that way. Okay, so this is the person table. In person table, I only print 10, otherwise it's gonna be a super long table, which contains 425 observations. Let's skip that part. Okay, you can see the variable map, and I think that's pretty much everything for today. And in today's lecture lab, I lead you to run Rasch Dichotomous model using TAM package. Okay, so that's pretty much all for today. Thank you for listening. Bye bye.